record button. Okay, everybody, thank you. Welcome for attending our August meeting. Tonight we are Oliver doing a presentation on summertime Varroa treatment. As soon as we are done with our very short club business, we will open the floor to honeybee questions. We will introduce our speaker soon after. So we need some butts in seats for this coming Saturday, August 20th. For Eureka Natural Foods in McKinleyville and ENF in Eureka from 9 a.m. to 5 p.m. We will have a sign up genius soon that we'll send out via email and post on Facebook. So it's just a one-day event to share what we offer to the community. We might even have some demo hives. So we missed the roundup that they do, but we're looking slotted for next year, which is good. Membership dues for 2023 can be paid as soon as December 1st, 2022. And after the main presentation with Randy, we will have Q&A right after, so feel free to type in your questions in the chat or wait until we unmute mics at the end. So prizes today, in the prize wheel at the end like usual. All paying members are already entered, and we'll figure out how to get prizes to you, whether it's meet or pick up. Please note that you have to be present to win. Prizes include a new smoker donated by Hank. Hank's out of town, by the way. We have a silver amber necklace made and donated by Sarah Browning. I'll show pictures of these things here. We have a signed copy of Dewey Caron's 3rd edition Honeybee Biology book donated by yours truly. And we have a set of 4 honeybee mugs donated by Janine. And we have another subscription to American Bee Journal donated by DeDaunt & Sons. And we have a long sleeve knitted yellow bee sweater donated by Janine. So that's what we got. Some new business. We're looking at the possibility of making an HCBA calendar for 2023. This will be a great fundraiser for us and allow us to share some awesome beekeeping photos from right here in Humboldt County. So stay tuned. Event. There's a mead making workshop at Humboldt Beer Works in Eureka, and it's this Saturday on the 6th at 11 to noon. Free workshop for ages 21 and older. The event has been posted to our Facebook page. Hey, there you go. So that sounds awesome. I'm going to be working apiary, so I'm not going to be able to make it. Education committee. Hank's out of town, so he couldn't make this meeting. We still have Alberta Mariscotti and Dick LaForge, and we have Sam Ramsey on October. Is Dick here? Not yet. So I think he might be out of town in September, I heard. So we might have him do a pre-recording maybe, or turn him into a hologram or something.
Dick will be back by September 1st.
Okay, thank you. We have 93 paid members, which I think is a record. We had 2 come in recently. And our swag, HCBA swag is available up on our website. So then after the presentation, I will post some information about donating to Randy Oliver's research. So I'll do that at the end. That's all I got. It's a short and sweet list here. Yes, Chris.
I just wanted to remind people that we do have some extractors that we have available for members to rent. And it's in McKinleyville, so contact me.
Yeah, honey harvest is coming. I got some heavy boxes. I don't know about you guys.
Mine are still packing it on too. It's not ending.
I know. I've definitely noticed the Himalayan blackberries are slowing down, but they're still bringing in the weight for sure. So I want to open up the floor to just some general bee questions. Question and answer time. Anybody? What's new? What are your challenges?
I have a question.
Yeah.
This is Mary. So I've got a lot of new hive components. When the Himalayan blackberry bloom is over. They pretty much stopped building new wax, but they're still bringing in nectar. So I'm not sure, what do you do when you don't have built out comb for your bees? Do you just hope that they slowly build a little bit of wax? I'm just afraid that they're gonna be backfilling at this point instead of building out new comb, or maybe I'm misunderstanding what it is that the bees are going to be doing when there's still some nectar, but not a lot. They're still bringing stuff in, but it's not like it was a month ago. So I don't know how many empty boxes I should be putting out there for them with new foundation.
Right. I've always been careful about adding boxes in August, but,
Right.
but I don't know.
Yeah, usually our nectar flow is subsiding by the first week of July, or at least the second week of July. And it
Mine was the
generally
second.
does no good to add boxes
Right.
beyond, the end of June. This year it seems to be a little different, but I would still be wary. Let's hear what Oliver has to say.
Okay. The question I always ask when people ask me questions is what's your goal? What is your goal? Why are you even asking this question?
Yeah, my goal is to prevent the bees from storing their nectar in places that they shouldn't be.
So let me ask you a question. Do your colonies already have enough honey to make it to the winter?
Yes, I think so.
Okay, and are you going to extract any of that, or are you going to leave it on them for winter?
This year I will be extracting some of it, yes.
So then you will probably have to feed them back unless you leave them enough.
Yes.
Okay, is that what you're planning on doing?
Yeah, I'm planning on leaving them enough, but I think there's still enough to pull off. I'll pull off some.
Okay.
Last year I left on a lot and I froze some for them.
Okay, so with a light flow on now, bees will not touch foundation until they've filled all the available empty cells on the outside of the brood nest in the brood chambers. Until they run out of space, they're not going to produce any fresh wax. So as you taper off after the blackberry like this, it's unlikely they're going to be drawing much more wax unless you get a surprise flow. So, and the reason I asked for the goal is unless I know whether you're trying to put on more stores for winter or you're short on drawn comb. So if you're not short on drawn comb and you already have stores, then there's
I'm short on drawn comb because I'm relatively new. So had some splits and swarms that I collected. So I don't have those resources to just.
So that's what I'm asking you. What's your goal? Are you trying to draw additional comb?
Yeah.
Okay, then you're going to have to feed heavily to draw additional comb. The question, again, every single question, I'm going to start with what's your goal?
Yeah, okay.
Until you define your goal clearly, and this is going to help you tremendously in beekeeping, to always define your goal. Is it to build up for a pollination event? Is it to draw more comb for some reason? And once you have a goal and your reason to figure it out, then you can back calculate what to do.
Okay, that makes total sense. Thank you.
You bet.
Sounds like scientific beekeeping right there.
It is, yes. So tell you what, I'm going to try to get done by around 7:30.
Okay.
So if I get going, I'll have time for some more question and answers after that.
So how about we get started with the presentation and we'll open up some Q&A at the end.
Great.
Okay.
So
Okay.
I'll go ahead. Let me share my screen. Or go ahead.
Okay, you go, Randy. The floor is yours.
Okay. Slideshow from beginning. All righty. Can you guys see a yellow slide right now?
Yes.
And does it change to green?
Yep.
Okay, so now we've done our testing to see that it works here. And what I focus on is not basic research, but applied research, research that beekeepers can actually use out in the field for their management decisions. And so I started off kind of ambitiously this spring and we've completed already a number of projects, and we have some other ones in progress. So in presenting, people are asking me what I'm doing, and they've been very interested in this. So that's why I just threw this together very quickly from photographs I took. So I just worked on it for an hour just before we came on here. So just so you understand where I'm coming from is, hang on, I want to hide. Okay. I've got three main areas of focus for applied beekeeping. One is colony nutrition, especially with pollen stuff. So I've wrapped up a very large project last 2 years on that. And then understanding Varroa. And so I created my Randy's Varroa model for beekeepers to use everywhere for planning your Varroa management strategies. And now we're deeply involved in our 7th year of breeding for mite resistance, try to have bees that manage Varroa on their own. And then the last thing, until we do have all resistant bees, to develop and test sustainable Varroa management methods. So things that will work for a long time. So what happened in our operation is after Varroa wiped us out in the 1990s, we hopped on the fluvalate, the apistan strips, and after about 6 years, the mites had developed resistance. So we switched to Coumaphos. We did that for 1 year. That was scary stuff to use. And within 3 years, they had developed resistance. So at that point, I got soured on the synthetic miticides because of the very rapid development of resistance. And I did not consider them to be sustainable, especially with the comb contamination involved. So we haven't used a synthetic miticide in over 20 years now in our operation. And we're only using the oxalic acid, the Thymol, and formic acid in rotation. So that's what the rest of this presentation is going to be about, on focusing how to use those three. So first, I pulled this off of the other presentation I was going to do the concepts of Varroa management, and I just summarized them very quickly for you. So the first thing, you can't just understand bee biology, you need to understand Varroa biology, and I have quite a bit written on that. And then plan your strategy for the season. And this is why I'm saying, focus on your goals at each time point. You know, is wintering your toughest thing? Are you trying to prepare for pollination contracts? Are you trying to prepare for producing nukes? Are you trying to avoid swarming? So get your strategy, and then use my Varroa model to plan your mite management strategy around what your goals are. Now, the most successful beekeepers are those that are proactive rather than reactive. Instead of when many beekeepers saying, "Oh my God, I got a problem," the proactive beekeeper 2 months prior had already avoided getting that problem because they were proactive. And this especially applies with Varroa mites. So to be proactive with Varroa, you want to get your mite population infestation rate down to close to 0 early in the spring, prior to swarm season. The mites reproduce at their highest rate, our most successful reproductive success, during swarming period, when they have the most amount of drone brood and the highest ratio of brood to adult bees. So if you can nip the infestation in the bud prior to swarming, that helps you out for the rest of the season. And then you want to zero it again before your autumn brood rearing, before they go into winter cluster and produce winter bees to make it through the winter. So for most people, that means middle of August, you want to zero your mite population, so your last rounds of brood are free of mites and free of viruses. And then we do a winter cleanup, typically just before Christmas, with an oxalic acid dribble. And that just is amazing how that starts your bees very good in the following springtime. You do want to rotate treatments. Beekeepers are always saying, "Oh, Randy, there's a new treatment, so can we just put it on year round?" Well, as soon as you put a treatment on year round, you have entered into a selective breeding program for resistant mites. So what you want to do is rotate your treatment. So we use all three of those, Thymol, oxalic acid, and formic acid, in rotations throughout the year. So you hit the mite from a different angle at each time, so you're avoiding breeding for resistance. And if you do these things, you're going to have healthy, productive hives all season long. So I just added this slide to my first year of beekeeping. And what it shows is, this is from my Varroa model, what we have found in our array, the most appropriate type of treatments to use during different periods of the season. So due to temperature, due to the amount of brood, due to whether there's honey supers on, there's treatments that are appropriate at at certain times. So again, this is, I just added it to my first year beekeeping webpage. So you can use these suggestions to plan your management strategy. This just to show you, not for anybody to copy it, but this is what we've done for 20 years. We are almond pollinators, so we're different than recreational beekeepers. We bring our hives back in early or mid-March, very, very strong, and we split them hard, create an induced brood break with a queen cell, and we treat them with an oxalic acid dribble. That takes our mite counts way, way down. These would be our mite counts, and we're usually actually down to that 0 to 1 range here. And that buys us time until usually about the 1st of July. Now we still have honey supers on because we're finishing up the blackberry flow. So we'll throw a single Mite quick strip or Formic Pro pad into the hives at that time, just to knock the mites back a little bit until we can pull the honey, typically in early August. And then we mid-August, we typically use an Apiguard, a Thymol treatment, because at that time we don't care about the brood reduction done by the Thymol treatment, because none of the bees that are reared during August are ever going to make it through the winter. So we can hit the brood hard with a Thymol treatment. Then once we're done, because we want to build them up for almonds, we do feed protein. If you're not going to be an almond pollinator, you don't need to feed protein at this time. And then we do our oxalic acid dribble. And we've used this for, like I said, 2 decades. And the successful rotation works well for us. But it's not, again, everything has to be based upon your own environment, your own plant. Now, the one thing universally that I hear from beekeepers is, how do you manage Varroa during the honey flow when you have honey supers on? You've gotten past swarming season. Even if you reduce your mite population greatly here, they're going to build up a lot during the honey flow. And the longer you wait for your supers, the harder it is to manage it, because as your brood diminishes, your infestation rate of your adult bees gets very, very high, which means the nurse bees start getting infested and viruses go epidemic in the hive. So you really want to figure out how to control Varroa during the honey flow. And there's only 3 treatments that are approved for use during that time. That's formic acid, HopGuard, and oxalic acid. So I published research on HopGuard last year, and 2 to 3 treatments during the honey flow can be efficacious for that. For us, it's a little bit pricey and time consuming to apply. So we've been using formic acid and oxalic acid quite a bit. So my focus for research this year is on summertime mite treatments. And what I'm looking at is mainly extended release methods. So taking those 3 treatment active ingredients, oxalic acid, formic acid, and Thymol, and see if I can extend the release of those treatments by tweaking the application methods. So this is what I'm looking at right here. So first, oxalic acid. If you're a Californian, pretty much you grew up sucking on sour grass, which is Buttercup oxalis. That's what oxalic acid is named after. Here's my grandson sucking on a solution of sugar and oxalic acid right here. It tastes like lemonade. And when I travel to other states, I tell them that all Californians do this as kids. It causes irreversible brain damage, and that's why we Californians are the way that we are. And that always gets a chuckle from any other state. And most people apply it during the dribble method. And this works very, very well when the colonies are broodless, either due to winter brood break or an induced brood break created by the beekeeper, such as we do after almond pollination. But it's not very efficacious if there is brood present. The other one people are using a lot is the oxalic acid vaporization. And now with these very rapid acting guns, thinking that it's going to be as efficacious. And the question is does it do much when there's brood? And I've studied data sets from quite a few beekeepers, analyzed them deeply, interviewed the beekeepers. I'll be writing a paper on this, looking at just how efficacious oxalic vaporization is while there is brood in the hive. Here's an example from a Seattle beekeeper. He did vaporizations every 4 days, all the way from August to December. Now, if it were efficacious, you would have seen these mite drops going boom, right down to 0. You can see here, even with vaporization at 4 days, it may take a long time. And typically most people are going to take 7 or more vaporizations to get the mite count down. One of the reasons is that the approved application method by label is only to put 1 gram per brood chamber. So that'd be 2 grams for a double deep. Recent research by Cameron Jack is showing that is inadequate for high efficacy. It really should take 2 grams per brood chamber, maybe even 3 per brood chamber to get good efficacy. But that's not approved yet, so I'm not recommending this. So I was curious then, what if instead of vaporization, we did multiple dribbles? So you're applying roughly the same amount of oxalic acid to a colony with the dribble method. So we did dribbles of 5 milliliters of oxalic acid in 50% sugar syrup. Now there's a problem with the sugar syrup, and this is the only registered treatment in the United States to put on sugar syrup. And that is that the sugar, the taste of the sugar induces the bees to suck up some of the oxalic acid into their crops. And then if they digest it, that affects their guts. It causes tissue apoptosis in their intestinal tract, and they will feed some of it to the brood, and that can cause brood mortality. So some beekeepers that I know of use glycerin instead of the sugar in here, and think that we have improved. So I also tested with in 40% glycerin. And then a guy named Halle Tamenma in Estonia, a very good researcher, recently published a paper I've been wanting to follow up with, and I've communicated with him a few times, of putting on instead of 5 milliliters, 20 milliliters or more. He tested anywhere from 15 to 50 milliliters and said 20 milliliters looks about the best for maybe distributing it better on the bees. And he tried it with sugar, with straight water, and then also with water and a little bit of Thymol. And the Thymol has some toxicity to the mites and also an irritation to the mites. Maybe it makes them move around and get exposed more to the oxalic acid. But the amount of Thymol he used caused some bee mortality. So what I did is I mixed mine up with about 1/3 the amount of Thymol he used, just enough to irritate the mites, but not necessary to cause adverse effects on the bees. We set up a bunch of hives. We did 4 dribbles at 4-day intervals and took mite counts before we started and after we were all done at 21 days after this. So give the colony's time to get the equilibrium. So this is very tedious of measuring all these amounts in a whole bunch of hives. And here are the results. And I just graphed these out for you just a few minutes before we started. So here's the effect of 4 repeated dribbles on these colonies. Now the blue columns of all my graphs will be your starting mite count or colony strength or the starting number. And the matching red column will be your ending. So this is the June 7th count, and the red are the June 24th count. If you have high efficacy, you're not going to see much red. You're going to see all blue. And you can see only with the 5 milliliter one do we see much blue, but we still see way too much red. And with the rest of them, we just didn't see much at all reduction. So disappointing as far as Varroa reduction. We also graded the colonies for strength, how many frames of bees there were in early June and how many frames of bees there were towards the end of June to see if these repeated dribbles had an effect on colony strength. Look at our control group. They all went up in strength. See the red here, all went up. Look at all the rest. Most of them did not do that. So apparently there was some adverse effect on the colonies from those 4 repeated dribbles. So this is interesting. I haven't seen much in the way of study, either from vaporization or the oxalic dribbles during the summer by doing repeated treatment. So there may be an adverse effect here. Any burning questions on this experiment? Okay, on to the next. So on oxalic, some take-home messages. First, it's a food-grade miticide. FDA is not at all worried about it getting into the honey or bothering you. You get plenty in your diet. So the amount that's in honey is minuscule. I found the liquid application is much safer for handling than either handling formic acid. Now we use a lot of formic acid. We buy formic acid by the 55-gallon drum. So we're very familiar with formic acid. It's also much safer than oxalic acid vaporization to the applicator. So when my crew, when we've used these acids for many years, And I started playing with vaporizers a couple of years ago. They go, why in the world would anybody use an oxalic acid vaporizer? Across the board, my crew just was not impressed with them whatsoever. There's other ways of using oxalic acid. And I'm not trashing the vaporizers, but I'm just saying what my crew, every person felt. Beauty of oxalic, there's usually almost no setback in brood rearing, which you have for many of the other treatments, and we don't see any queen issues. The limitation is that it's got very poor efficacy if brood is present, as I just said. So the Magi group from the Aluen Coordinated Action Project down in Argentina, 2015, published a paper with a great idea. How about doing an extended release oxalic acid? So instead of multiple applications, you dissolve it in glycerin, put it on a cardboard strips and put them in the hive. So this is very interesting. And since it's not a legal application method in California, I do get a pesticide research authorization every year to do this. So I need to cover my butt here. This application method is not yet approved by EPA. Randy Oliver does not advocate or encourage use of this treatment method without a permit. Okay, you all clear on that? Okay, the good news is, even though the EPA, and I've been all over the EPA, they're dragging their feet on this, it's not registered. The oxalic acid is not registered for use at all anywhere in California. I'm the only beekeeper in California who can legally put oxalic acid in the beehive, okay? In order to kill mites. Any beekeeper can put it into a beehive to bleach their top bars, and that's totally legal as long as your thought bubble is not that you're trying to kill mites, okay? So watch your thought bubbles. Now, some states are getting pissed off at the EPA, and I just got the email from Vermont. They just went around it and they just approved it for use by the beekeepers to use the extended release method in Vermont. EPA also, this doesn't apply to California, but they do not require pesticide research authorization for experimental use for this by any beekeeper, as long as you're not doing it over 5 acres worth of bees. And how you calculate that, I don't know. But I'm not sure that our state agency allows that. So just be cautious. So let's look at extended release oxalic acid. So I've tried a number of matrices. I started off with the cardboard strips. I tried the blue shop towels. And then we went to the Swedish sponges. And these work very, very well. Very happy with these. We've also tried some other industrial absorbent pads, but most of them have fire retardants and synthetic polyethylene fibers in them. So they're not totally biodegradable, and you're also adding other things to the hive. So I wondered, what if I would like a totally biodegradable application method? And the Swedish sponges are. When I put these into the compost pile after use, they completely biodegrade. They compost beautifully. So I wanted to try some other pure cotton fabrics. So I cut up terry cloth, pure cotton sweatshirt fleece, which is really hard to find. Almost all sweatshirt fleece has polyester in it. And then I tried a number of pure cotton battings, and many battens also have polyester. And I found one brand that was strong enough that I liked here. So I wanted to try these 4 and compare them. And I compared the, I'm trying to move my picture way here. Come here. Okay, you weigh it before you let it absorb the oxalic acid solution. You weigh it afterwards, and you see how much it absorbs. And typically the sponges, we get 100 to 112 grams of solution absorbed per sponge. The terry cloth absorbed even more. The sweatshirt fleece, much, much less, and the cotton batting just about the same. So these 3 looked especially good. So we ran a trial with these here. We prepared them. So here's the black sweatshirt, or those gray sweatshirt fleece, Swedish sponge, terry cloth, and the cotton batting here, which I was really excited about this a lot because it's very, very inexpensive. We applied 2 strips of each to 56 hives in 2 different yards and May 27th. 1 yard, a very dry yard, and 1 yard with a nice nectar flow. So here's the what's that? That's the cotton. That's the terry cloth, the cotton batting, Swedish sponges, and the sweatshirt fleece right here. And here are the results after 66 days. So starting mite count in blue, ending mite count in red, you want to see a lot of more blue than you see red. So here's yard L. It had a nice bloom and no colonies died, even with the high starting mite counts, and pretty good control with the cotton felt. Very good control of the Swedish sponge, and there's always a variability from colony to colony, which has a lot apparently to do with drifting bees. Some colonies are more attracted to drifting bees. So all these had very good reductions of 84 to 92% from the starting mite count. So we're pretty happy with this across here. Then we went over to the dry yard. Same number of days, all applied the same day. And the reductions were much, much poorer for all except for these Swedish sponges. We got very good reduction. But the amazing thing was when we looked at the other pads, they had all dried out, bone dry. These were all still juicy with glycerin in this yard, and they dried out. Plus, in this yard, a number of the high mite starting colonies died. And I go, wow, now that's interesting, because I thought that was an anomaly last year that we found. We can generally put these on in late in the season on hives, like in August, with colonies up to mite counts of like 90, super high, and they can clear the mites. But when last year I put some on in the early spring, they did not, they died. And the same thing happened this year in this yard. So I'm not sure whether it has to do with the timing or what, of why it might. I don't have enough data, but it indicates that possibly it's better for a later season treatment than it is for an early season treatment. Just so you know, my sons are doing really happy with putting on an extended release pad and a Formic treatment at the same time early in the season. Formic for a quick knockdown, and then the extended release for then slow hitting of the mites. So what I was curious about is how much residual activity there is from oxalic acid, how long it actually has an effect in the colony. So I looked at the different application methods by the EPA label of how much they say to use and how many bees to put on, how many frames of bees or what size box. So you can calculate it's about 2,000 bees per frame of bees. And you can calculate, divide the total amount by how many bees, and it comes up for the dribble application, a little over 100 micrograms, millionths of a gram per bee, if it were all theoretically to go onto the bees. For the spray application, for packages, it's the same amount, right around 100 micrograms per bee. And then for the vaporization treatment, it was only 50 micrograms per bee. But like I said, the recommended dose or approved dose is only about half of what you need for good mite control. So that also was right around the 100 micrograms per bee. So we already have now a baseline figure based on the label. We're probably looking at, we want something around 100 micrograms per bee for good mite control. You guys all with me on this? Okay. Now, how do you figure out how many micrograms are on bee? So in 2018, I set up a big trial. I started doing titrations, chemical titrations. We collected hundreds of samples of bees from the hives after doing different kinds of application methods of oxalic acid. And then working at the bench, pulling them out of the freezer and doing cage trials and stuff, titrating, I found out, wow, they titrate with so many micrograms when they're fresh. But if they sit on the table for a few days, it goes way down. And I did research on this, trying to figure out why would it get neutralized on a bee's body. If you put it onto shrimp chitin, shrimp shells, it neutralizes almost instantly. But shrimp shells have calcium carbonate, limestone in them, which will neutralize the acid. All the literature I've seen on insect chitin says there's no limestone in it, no calcium carbonate. So I was curious about this. This has been bothering me since 2018. It's been on the top of my to-do list to do these titrations. So let me just show you what it is. So we take a test tube, put in a measured amount of distilled water, put in a indicator solution, bromocresol green, and then get it to this blue color. We like to do it just shy of the cobalt blue, so we can see if we overshoot. Then we drop a bee in. If there's any oxalic acid residues, actually, I shouldn't say oxalic, if there's any acidity to that bee, it turns it towards orange. 100 micrograms will make it look this orange color right there. So we're not testing for oxalic, we're testing for the acidity due to oxalic. And then we drop in a titrant solution, 1 drop at a time. Each drop calibrated to equal either 10 micrograms or 1 microgram, depending on which one we want. We do it 1 at a time and count the number of drops. And when the color goes back to the starting color, now you know exactly how many micrograms of acidity there were on that bee. And this is extremely accurate, quick, like 15 seconds, and very informative. So what about the disappearing from the bees' bodies? So I recently hired a new assistant, Rose, and I said, Rose, what I want you to do is pick up this project from 2018 and get this done this year. So I've been training Rose on this. So one of the first experiments we did is we took various solutions, our application method of oxalic acid, took some bees, put them in the freezer, freeze killed them, and then pulled them out and did a quick dip into these solutions, and then dumped them out on a paper towel to dry, and then immediately titrated them at a half an hour, 2 hours, 4 hours, up to 12 days afterwards to see what would happen. We also put some oxalic acid straight onto drops onto plastic cover slips, so no exposure to bees, to see whether it would degrade without exposure to the bee chitin. We also, didn't take a picture of it, but we did a vaporization, and I should be wearing a mask, of course, vaporization in a plastic cup, and got a light level on the bees and checked it microscopically. So here's under a microscope. You can see these little crystals right here. I'm going to blow it up. So these little crystals are oxalic acid crystals on the bees' setae, or their hairs. Okay, so this would be active oxalic acid that the mites could be exposed to. Here's the results. Okay, so this would be for 10 micrograms. This would be 100 micrograms right here. Okay, right here, this is the oxalic acid on plastic. This one right here, no change up to 10 days. 12 days later, it does not degrade at all. But if you mix it with glycerin and put it on a cover slip, it does degrade substantially, fairly quickly. We didn't run that one for 12 days. I can't remember. We ran out of cover slips because this was preliminary research and we didn't make enough of the cover slips. Okay, so over here, vaporization, that's the red line. It also degrades pretty much. This is after 12 hours. This is after 1 day. So after 1 day, you've gone from 100 down to about 70 micrograms on those same bees. And then we have the oxalic acid in the sugar solution here, and that degrades very, very rapidly initially. So it's dropping from 130 micrograms in 1 day down to, we're talking like 40 micrograms. So you're maybe 1/3 after a day is still acid, so very rapid. Also the oxalic in the glycerin, this orange, very, very rapid drop in the glycerin, and we get down to close to 0 after 12 days. My samples that were frozen in the freezer, so we did oxalic acid just in water, would be the dark blue line. That degrades. We put them in the freezer and took them out each time. They still degraded at slightly slower, but almost the same rate. So this baseline data told us oxalic acid, once it's on bees' bodies, even if they're dead and dried, degrades fairly rapidly. So this was to establish our baseline here, our lab work. So then we went out to the field. We started putting it into colonies in the field. And here's Rose right here. I built her a special table, and so we have a portable system out here that we can do hundreds of titrations right in the field very quickly. And here what she's doing to get low levels of acid, she puts 10 bees into the solution, so we can figure out the average number of micrograms, millionths of a gram per bee, just divided by 10 right here. So the way we do this, we start off with our vials all calibrated to the same color. We like this just kind of off blue, bluish green color. That lets us know if we overshoot. It turns cobalt blue, we know we've overshot. Then it was hard picking up 10 bees at a time live and putting them in a test tube because they want to crawl out. So I took my carbon dioxide applicator here, then we have these little vials with a hole in them. We can just put the needle into here and give them a little shot of carbon dioxide. And this knocks the bees out for a few minutes. So then we can very rapidly drop the bees into here. So you see here, we hold one in each batch to the original color. Don't put any bees in it. And then we can compare the colors of these to that and add the titrant until we match this color back exactly. So here we have put 10 bees in each one, and you can see here's the reference. And this one had the most acid, this one had less acid, and this one had less acid right here. And then we'll titrate them all back till they match this color, and then that'll tell us. So here they are back matching this color here, and we know that this was 50 micrograms altogether. So 10 bees, 5 micrograms per bee, 6 micrograms per bee, and 3 micrograms per bee. And to go back to here, so that's 3 micrograms, 5 micrograms, and 6 micrograms per bee. So we're pretty low numbers per bee. Okay, well, I don't have the results of that yet. We're going to get a lot more results on this yet. We wanted to standardize with vaporization and with the dribble. At that time, I just finished the data I showed you from the cotton matrices. And I go, wow, we've got these sponges still in these hives after 73 days in hot weather. Why don't we go out and just pluck some of these bees right out of these hives and see how much residue is on their bodies after being exposed for 73 days. And people are saying, Randy, doesn't that oxalic acid build up in the hives? Doesn't it hurt the queen? How did the bees deal with all that oxalic acid? We're putting 50 grams of oxalic acid into a hive. So we tested it out, did a whole bunch of counts, prepared our titration tubes, and then put the right on top of the top bars here. And then I could just pick bees right off of in between the frames and drop them in. I'm doing 3 bees per sample here. And you can see very low levels of oxalic acid. And here's our reference one right here. And see the bees, they walk out. This doesn't drown the bees. If you do it quickly, you can flip them right out and the bees are just fine after this because it's just water solution. And when and this is a control. So this went to a hive that had not been treated with any kind of oxalic acid, and there's no change whatsoever. Every control hive we've ever done, there's no acidity on the bees. So here's the data. So I did it from 3 different hives over two days, subsequent days, titrating either 10 bees, 1 bee, 3 bees, 5 bees, the control bees. And when we look at our oxalic acid equivalence, the amount of acidity per bee, we're looking at typically that 2 to 3 micrograms per bee in those treated hives. So very low residues, 2 to 3 micrograms, compared to the 100 micrograms that you're putting on with a full dribble or spray or vaporization is very low. So now the question is, how can that very low level of acidity affect the bees? But this was at 73 days. So what we're curious now is, how about after 2 days, 3 days? So this is going to be our next experiment. We're going to set up all these different kinds of hives with the vapor application, dribble application, different kinds of solutions, different sponges, the New Zealand strips, the arginine strips with different ratios of glycerin and propylene glycol instead of glycerin. And also I just added, I haven't shown yet, we're going to try citric acid also to see how that works. So this experiment we're going to be, we're setting up right now. We'll be running this starting in a week or so. And we'll track these over time. We already know that these will all be pretty much disappeared after 12 days. And then we'll look at these over the long term and see whether we have a, where that spikes, where it drops off, and maybe compare it to the daily mite drop from these hives. Okay, so we found out last year that when we took our colonies up to our high elevation or isolated yards in the high Sierras or in Nevada, that the oxalic acid worked, extended release worked incredibly well, just zeroed out the mite counts because there was no mite immigration. If you got a bunch of other hives around with high mites and that low level of oxalic acid is not adequate to kill them, you don't get as good control. And so here's just some data I had from a few years ago. I haven't published this yet, where we had a bunch of hives and we measured mite immigration coming in from outside twice a week. And you can see between middle of September and November, almost 500 mites came into that hive. And you can get 1,000 or more mites coming into a hive during the summer. And these were not from our colonies. These were apparently from escaped swarms or failed colonies. This was one of the higher ones in the number that we tested in my yard. But this is a real type number. You get a lot of mites coming in. So I had a manufacturer or bee supplier from New Zealand saying, "Hey, Randy, we got these new models of these anti-robbing guards, and curious how well they work to stop mite immigration, and for yellow jackets and for robbing." And I said, "Well, I'll tell you what, if you want to send me a bunch, I'll run the tests on the beekeepers.dollar." So they sent me a bunch, and we're just setting up this trial right now. We're going to test them to see if they do reduce mite immigration coming into the hive. And then we're setting up 100 colonies to see if they increase the efficacy of the extended release oxalic application method. So that's this trial we are setting up this week. Okay, let's move to formic acid. When I talk about formic acid during the summer, everybody says, "Well, how about queen loss?" And yes, 2 years ago, we did a large trial and found out, yes, you do have a lot of queen turnover, although the colonies generally are able to requeen themselves if you use the one strip repeated at 10 days, but a lot of queen loss. Something that we do, and here's a tip for you guys. We have often in hot weather, 5-frame nucleus colonies with new queens. And we want to reduce the mites, but we didn't want to kill those new queens. So we take a formic strip and cut it in half crossways right here, lay it on the top bars, put the lid on, and then stand on the lid. That smashes the lid down over the top surface area, which means no formic acid can evaporate from the surface. From the bottom, no formic acid can evaporate from the 3 top bars that it's sitting on. So the only evaporation is around the 4 edges and the gaps between right here. So it greatly reduces the acid evaporation rate. And what we find is, if you put the strip in a double deep between the brood chambers, after 10 days, they are stiff and there's no more acid smell at all. When we do it here, and this is my helper Tammy, and Rose getting her first whiff of testing a strip to see if there's formic acid residues. And yes, you can see by her face, very strong residues. If you cover the top of the strip, after 10 days, you still have plenty of formic acid in these strips right here. Now, this goes to a paper published in 2001 by an acarologist, a mite expert from University in the East Coast, and Bob Noel. You may not recognize Bob Noel's name. He's the inventor of Honeybee Healthy, the mixture of spearmint oil and lemongrass oil. And what they published, this is a quote: "Essential oil components of Honeybee Healthy modify the effect of formic acid treatment on beehives such that queens are not lost. This aspect is extremely important for any beekeepers using formic acid to treat Varroa mites." This aspect is extremely important. I have searched the literature for any follow-up research on this, and I've asked the manufacturer of Mite if he's followed up on it. I can't find any follow-up research on this at all since 2001. And I would think, so I wanted to do some follow-up research. So I last couple of years, I put some queens in pushing cages with or without attendants, and put them directly underneath formic pads and treated the colonies with some pretty strong doses of formic acid, enough sometimes to kill the attendants. It does not necessarily kill the queen at all. So the question is it the formic acid killing the queens, or is it the workers killing the queens in response to the irritation? So we were out in the yard earlier this spring, and my son Eric phoned me up and said, "Hey, Dad, we're coming over to the same yard you're at. We're gonna formic some of the dink, the really weak single hives that have lousy queens, and we don't mind about killing the queens." I said, "Oh, Eric, can you find a bunch of pushing cages and bring them over so I can do the experiment to see if we can use the Honeybee Healthy?" And he couldn't find the pushing cages, and he was in a hurry to go. And he says, "I'll tell you what, I'll bring you some JZ's bees in cages." So not the experiment I wanted to do, but so we found the queens in each colony and put them in a JZ's bees cage here without any attendants and without any food. And then my son said, well, we don't want to, on the really weak colonies, the 4-frame or weaker, we don't want to kill all the bees. So we will put the lid down tight on top of the Formic strip. On the ones that are stronger than 4 frames, the 5 to 9 framers, we'll put an 1.5 inch rim around to allow the Formic to evaporate from the top to get better mite efficacy. Y'all with me on that? The weak colonies, no rim. The strong colonies got a rim. We went back after 2 days and checked for queen rightness. So the weak colonies, 2 to 4 frames of bees, very, very weak colonies with lousy 2nd-year queens that were not doing much that we wanted to kill. Most of them were still alive. The ones in the rim, which are 6 to 9 frames, most of the queens were dead. So it really, but we don't know whether it was due to the Formic toxicity or due to the lack of the attendants feeding the queen through the cages. So I'm still trying to come up with a method that I consistently kill the queens, so I can see then if Honeybee Healthy will prevent that. So this is research still in progress. Now, independent of Honeybee Healthy, we did do some more research on covering strips. So what I did is I took some double deep chambers of drawn comb without any bees. So remove the bees and their fanning. Wait till the temperature gets to like brood nest temperature, 95 degrees during the day, and then put in Formic Pro strips and take the wrapper, the Mylar wrapper, and put it over the top of the strip and then put the second box on. And then go back every day and weigh how much weight loss there was, which tells you how much formic acid evaporated. This is kind of the optimal range for mite control right here. And you can see for the uncovered strip, big blast of formic acid the first day, and about half of it for the covered strip. What's interesting is after day 4, you're getting more formic acid released every day by the covered strip than you did from the uncovered strip. So the question is, here in the US, we use the Mite strips. In Canada, they use the Formic flash, where they pour liquid formic acid on, and they get a big flash for a few days. In Germany, and also with the mite drawing pads from Bill Ruzicka, they do keep it in this range with a long extended release. So I'm curious whether by avoiding the flash, we can avoid killing the queens and maybe get better mite control. So we set up trial. We took a bunch of colonies, so we had 2 different yards. So the first yard, we put on a single strip and put the wrapper over it and put the second brood chamber on top for all the colonies in that yard. And then came back 10 days later, put a fresh strip underneath the same wrapper, and then waited until day 21 after the first treatment, which allows the mites in the brood to come back in equilibrium with the mites and the bees, and then check for the amount of mite reduction. And here we go. So this is 1 formic strip covered, applied 2 times. And these are colonies now are by strength. So these are 6 frames of bees up to 26 frames of bees. So the stronger colonies over here, weaker colonies over here. Notice on the weaker colonies, we got better mite reduction, more blue. Oh, this was a good reduction here. But not great mite reduction. You know, we see a lot of blue, but when I compare this to what we did in 2020, 2 years ago, in the same yard at the same time of year, our overall reduction of about 54% is about the same that we got then. But back then we had a whole bunch of queens replaced. Here we had 0 queen loss. Every queen was still laying at the end of this trial. So we got about the same amount of reduction, but with no queen loss. So that's a take home for you there. If you want to avoid killing your queens, covering the strip with the foil might help. Now in the other yard, we only gave them 1 strip, either covered or uncovered. So we ran a test and control group, either covered or uncovered. And we only put the 1 strip in, then after 21 days, also did a count. Now this is not a full treatment because it was only 1 strip, but we wanted to compare the difference in efficacy from those. So the uncovered strip right here, you can see a lot of red still, so not great efficacy. And in the covered strip also not great, but we only did one treatment. In this yard, we only lost one queen, and that was in an uncovered one. And we were surprised how few queens we lost with the uncovered ones. So it looks like the efficacy is roughly the same covered or uncovered. So the take home from this is if you want to avoid queen loss, put the cover over one strip. And we need to repeat this more to see. Now, we still have some hives with high mite counts. We go, well, maybe we should go back and try some more experiments. What if you put 2 strips in, but left them in the wrapper and just cut the ends off? And now you only have Formic evaporating from this end and from that end. And we put them parallel to the frame, so the evaporation would be right in the brood area rather than out into the honey area. And after we applied a few of these, one of my helpers said, Randy, what if we cut them in half and had 4 ends exposed? Now we'd have Formic going well distributed throughout the brood nest. So we have a number of these in these hives right now. And the interesting thing was, then we put also entry reducers in every hive to trap the formic acid inside, because now we're doing a big 2-strip treatment, but very slow release. And by reducing the entrance, we trap it in there. We get a little bit of bearding the first day and almost none afterwards. Now, normally formic acid, if you do a full double strip treatment, it will kill the grass in front of the hive. Our grass was already dead, so we couldn't tell. So I did the other method where you stick your nose right up to the hole in the entrance where they're fanning and you sniff for formic acid fumes. If I put in a single strip covered on the top side, it'll make my eyes water and lots of formic acid fumes. All the ones where we only sniffed the ends of the strips, I couldn't smell any formic acid fumes at all, even from day 1. So, and very little bearding also from that. So this is an experiment in progress right now. In about 2 weeks, we will take final mite counts and see how well that works. Okay, last thing, moving on to Thymol. How are we doing for time here? Time and Thymol. 7 o'clock already. Okay, I'm gonna blast Thymol quickly. Apigar gel, 12.5 grams. You apply it twice. If you put the 12.5 grams in the middle of the brood chamber, you tend to blow the bees out of the hive. Typically, and I've experimented, depending on how slowly it releases, that's 6 to 12 grams is the most you can put in between the brood chambers. I did an experiment a few years ago where we, in a number of hives, it's put 16 blocks, 1-inch square blocks, with different ratios of amounts of vegetable oil with the Thymol dissolved in it, and also different amounts of Thymol. And then we check back to see how the bees responded. If you mix the Thymol with vegetable oil, they tend to cover the block with propolis. If there's no vegetable oil, they tend to remove the block completely. I don't have time, but the bees reacted. So the bees fan the Thymol away, and then they chew the block once they get the residue down. But this thicker block gives a slow release of Thymol here. So I was curious, could we make some of these blocks up? And it's very easy for me to determine exactly how many grams of Thymol there are in these blocks. I simply dissolve the Thymol in denatured alcohol, saturate the block, and I can calculate, I know exactly how much they'll absorb. So I can make blocks with exactly 6 grams, 12 grams, whatever, very easy. You let the alcohol flash off in a few hours, and now you put these in a container. Now you have these precisely measured amounts of Thymol. I thought, wouldn't that be cool if we had a application method that the bees would just remove all this, that you wouldn't have to put cards or rims or anything on or remove anything. So here's a couple of them here. So I'm putting on 6 grams twice, so 12 grams between the brood chambers. And I did see they do typically will remove the eggs and young larvae, move the brood nest away. And then after a few days, the queens came back and there was no bearding with this. So I was interested in that. That's 12 full grams between the brood chambers and no bearding. So I said, well, what if we put on 24 grams total? spaced out around the rim, as you do with Apiolife var, or 24 grams between the brood chambers. Okay, so these are between the brood chambers, spaced out. Then I said, we didn't see hardly any reaction to this. They didn't beard out of the hives. So I said, well, how about 48 grams? So now we're up to 4 times the dose, either in a rim or down in the between the brood chambers. And this experiment is in progress as we speak right now. And that's the end. That's the end of our early research so far. Now we're getting into our serious research. And all our research is funded by beekeeper donations. And I will now unshare my screen. And we got a few minutes for a question and answer.
Awesome. Thank you, Randy. How do mites integrate into hives? Is it more drifting or swapping on bees when they're foraging?
I know there's a lot by drifting. I know they can swap by foraging, but I don't know how much of that takes place. The mites are not very much on foragers. So foragers are older bees, drifters are younger bees. Your mite infestation rate of the younger bees is much higher than it is on the forager bees. Okay, so the amount of transfer on the flowers, my educated guess would be less than from the drifting by the younger bees.
Right. Cool. What is the difference between a strip that is covered or pushed down to avoid total surface area than cutting a strip in half and not putting wrapper or cover down on top? In other words, isn't that a waste of a strip?
Well, it doesn't, the formic acid is still there. You're just slowing the release rate. The point is to slow the release rate, not putting on half the formic. It's the same amount of formic, it just releases slower. Does that make sense?
Yeah. Yep.
Okay.
What is the outside temp when you applied formic acid covered with the mylar?
Above 95 degrees.
Above 95. Okay. Have you experimented with reishi extract? Paul Stemets?
No, I have. I've talked to Paul and I've gone over the data strongly. And I'm following Brandon's research at Washington State. And it's of interest, but there's not enough hard data to draw conclusions.
Time will tell. I thought that OA was illegal. Yeah, it is illegal. How did you obtain it, Randy?
I have a pesticide research authorization by the state of California that I get every year. And you can buy 99% pure easily. There are bee supply houses, like Winter Sun in California that sells it, or on Amazon in small amounts. Yeah. Okay.
And then so oxalic acid vapor, the consensus right now is it just doesn't last. It doesn't stay in the hive as long as the dribble method or the Swedish sponges.
We only have very preliminary research, not enough for me to say. Okay. We'll be getting more on the well, first, you understand all this research, you first do quick and dirty experiments just on a single hive, and then maybe on a few hives. If you don't, first thing, you want to make sure you don't kill the hive. So you don't start off with 50 hives and kill them all. You start off with one hive and see if it kills it. If it doesn't kill one hive, then you do it on a half dozen hives. That doesn't kill them. Now you start looking at a full controlled trial. Controlled trials cost a lot of time and effort to do. So we do this quick and dirty preliminary research. And everything you're seeing here is quick. Most of it is quick and dirty preliminary research, unless you see those graphs with 50 or 100 hives, the data from that. So that comes afterwards. So right now we're just starting to move into the larger numbers.
Okay, you got time for a few more?
Yeah.
When your sons add Formic Pro strips and long release OA pads, do they put them all in between brood boxes?
Yes.
How many states in the US allow oxalic acid?
All but California, and not in the extended release form, but in the other forms.
Of course. Is OA vapor safe?
And it's not a problem with California. It's just a problem with the registrant changed. The USDA was working along. They decided not to be a registrant anymore, and then the Italian company that owns the registration now just has not moved. It's just bureaucratic, trying to move a bureaucratic mountain right now.
Yeah.
Very frustrating.
Is OA vapor safe to use with honey supers when used every 4 days, several times in a row, or only when used once in 1 gram per box doses?
Define safe.
Safe, as in safe to consume the honey.
It's always safe to consume honey. If you eat a serving of spinach, you can get 100. I mean, 100. Oh God, I can't remember. You can get a full gram of oxalic acid by eating a serving of spinach. We're talking micrograms, millionths of a gram. Okay, in the honey, or at the most thousands of a gram. So it's trivial compared to what you get in your diet.
Okay.
So if you're talking about safe, FDA is not concerned.
Okay, I think that's what you're asking, Angela, was it?
Yes, that's exactly it. Safe for consumption.
Yeah,
Okay.
if you ever eaten rhubarb pie, you'll be off the limits of oxalic acid that you just consumed.
So we should use rhubarb pie on our bees.
That possibility, I'm not sure. I'm not going to bother to collect data on that one.
What are the temperatures outside when you're experimenting queen loss? Here, with 50 to 60 degree days, I don't see queen loss.
Right. Like I said, we're often
From the heat.
having to put it on in 95-degree weather.
Right. All righty.
We don't choose that. That's just
That's what you get.
That's what
Yeah.
nature gives us. Okay.
Yeah. Is Oxalic is safe? Why is it illegal in California? It's a bureaucratic mountain, is what it sounds like.
Yeah. There's nobody is concerned about the safety of it. Okay. It's just dealing for somebody who's in private enterprise and used to moving quickly and getting things done. You try approaching the EPA and it's just like you're running into a brick wall.
Yeah.
I had a meeting, a Zoom meeting with them. I said, why don't you guys follow the New Zealand model? New Zealand said there is an own use exemption. Any beekeeper can use oxalic acid, formic acid, or thymol any way they want in their own hives, and they take full responsibility for nobody getting hurt. And I said, boy, if you did that, that would just cover your ass, EPA. You wouldn't have to worry about any responsibility. Put it all on the beekeepers and just turn us loose with those 3 safe treatments. And I said, you've already got the model of New Zealand. You can see that nobody's getting hurt in New Zealand. Why don't you just make it easy for us? Oh no, they're not interested.
Is the oxalic acid in stores, the wood bleach, is it the wrong form of oxalic acid, or is it?
I have not had that tested, so I really can't tell you. It's very easy to buy 99.6% pure online.
So if we needed to apply Formic in 85, 90 degree weather, is it correct that your research shows less queen loss if putting the mylar over the top of the pads?
Yes, that's what it appears to show.
All right. Yep. And the oxalic acid EPA approved is available from Man Lake.
Yes.
I got some. All right. That's the end of the questions. Well, thank you so much, Randy. We really appreciate it.
You bet. Yeah, I hope that you guys found that interesting. We're always on the edge of our seat, seeing how these experiments turn out and what we can learn from these, and then share it with beekeepers worldwide.
Yeah, it's almost like we're seeing it in real time with you.
You're seeing it in real time.
Yeah.
Some of those slides, I made those graphs for you minutes before we were went on.
Awesome. Well, thank you so much, Randy. We really appreciate you.
All right. Good night, guys.
Good night. Wow. That was awesome. Okay, so I got a plug here. So he does all his research by donation, like he said. And so Humble Beekeepers, we're gonna send a donation. If anybody wanted to send a donation, the address is posted in the chat. And there's also a PayPal link. That'll work there. Oops. If you just go to Scientific Beekeeping, that's his website. There's a donate link on the bottom if anybody wants to donate to his research. He says he spends $200 to $400 a day on paying people to do these research projects he's doing.
And buying cover slips.
Yeah, it's funny. It's like it must be an awesome family. They're all experimenting with their bees and kind of sharing research. It's pretty cool. Yeah, the Thymol was pretty quick towards the end. Yeah, boy.
Does
Okay.
anybody here use Thymol?
Yeah, Janine, have you used Thymol?
I certainly have used Thymol. I haven't used it in a while, but since I had, the chalk brood this spring, I am